Now let's use our knowledge of series to solve this expression. The limit as x goes to 0 of x squared times sine x minus x cubed over x to the fifth. So remember, when we're doing these problems, we're trying to substitute in a series into one of these values. So we know that the sine of the x, you can write that out as this power series. And let's rewrite this by substituting this in instead of sine of the x. So we get the limit as x approaches 0 of x squared times sine of the x, which we're rewriting, and I'm gonna stop right there. I'm gonna stop right there. That's minus x cubed, and all of that over x to the fifth. And something pretty cool happens once you multiply this out. So watch this. Well, x squared times x, that's just x cubed, minus x squared times x cubed, that's x to the fifth over 3 factorial, plus x squared times x to the fifth, that's x to the seventh over 5 factorial, and then dot dot dot, and then we're going to subtract an x cubed and divide all that by x to the fifth. Something pretty neat happens right there. And watch this. Remember how I put these parentheses around that to signify that that was the power series for sine x? I'm going to write that right here. Because look at this. This x cubed cancels out with that negative x cubed. And this x to the fifth cancels out with that x to the fifth down there. And what we're left with is x to the seventh over 5 factorial minus, that's going to be x to the ninth over 7 factorial, and the powers of x are just going to increase. Well, remember that we're taking the limit as x approaches 0. So all of these are just going to be 0 over some big number, over some factorial. So this is going to approach 0. So what we're left with is, well, this canceled out, we're left with a negative 1 over 3 factorial plus, well, that's just going to be 0. And that already canceled out with this x cubed. And then we're left with negative 1 over 3 factorial, which is equal to negative 1/6. So, I mean, when you look at this, that looks pretty junky and messy and hard to figure out, but once you rewrite that as sine x as its Taylor series, plug that in, it all simplifies out and we get a pretty nice answer.